Hello everyone, welcome to the channel Physics Fun. So in this video, we are going to discuss a very important topic in JEE mains, which many students, almost most of the students leave. That is communication system, right? So you can see the heading. If you watch this video is going to be 10 to 15 minutes long. If you watch this video, then definitely your marks in JEE mains are going to be increased by 4. Why I am saying this? Because I have compiled all the questions of JEE mains 2021 FAB attempt. I'm going to do for remaining attempts also in next upcoming videos. But when I have compiled all the videos, compiled all the questions of communication systems in FAB attempt, then guess what? All the questions were based on one single concept that is called amplitude modulation, right? So if you just understand amplitude and remember just one or two very simple things in amplitude modulation, you will be able to solve one question of communication system 100% in your JEE mains exam. And one more very important thing I want to say here, that there are 5, whatever were the number of attempts, right? In each and every paper, I found one question of communication system. Fine. So if you're targeting a percentile which is more than 99, this video is extremely important for you, right? So just 10 minutes and you get one question, 110% guaranteed, right? Okay, so let us see first question. Yeah, concept, I will come to this. First question is that there is a signal of 2 kilohertz. It is used to modulate a carrier signal of 1 megahertz. The bandwidth requirement for the signal is thus sideband frequencies, right? You're seeing many new words, sideband frequencies and all. These are all very simple. Just stay till the end and everything will be all right. You will be able to solve all the questions by yourself, right? There are 5 questions here. Fine. So immediately we'll go to the NCERT and read, and then one particular section which is needed for this, right? Amplitude modulation. Fine. Okay, so let's go there. Yeah. So here now, modulation and its necessity. I'm starting from here. Even before that, there are few important topics on which questions have come in some other sets also, and 2020 also, that I will be taking up in next video. Right now, all the questions in FAB attempt were based on amplitude modulation. And if I say that 99% questions of communication systems are based on amplitude modulation, then I think that's a correct statement. Fine. You will realize that, or if you are doing previous year questions, you must have realized this already. Fine. So very quickly, let us see. So here modulation and its necessity, right? That we will see. So I will highlight the important points here. See what happens when we want to transmit an electronic signal in audio frequency range, which is less than 20 kilohertz, right? Over a long distance communication, that we want to transmit a signal from one point to another point, right? So then we will now see that what factors prevent us from doing so and how we have to overcome. So basically, when you are creating a speech signal or any other signal, suppose this has a frequency of 20 kilohertz, then what happens? You cannot transmit this signal as it is, right? There are some problems in that. So first we will see what problems are there. So first is the size of antenna. Here now the key point is, right? This video focuses only on key points. So key point is that the antenna size should be the size comparable to the wavelength of the signal at least lambda by 4, right? Very important point. There are some questions which have come based on just this, right? Lambda by 4. So they have given frequency, and then you have to estimate the size of antenna. From frequency, what you have to do, you have to use this C equal to, sorry, you have to use this C equal to F lambda formula, and then you have to find C, 3 into 10 power 8. Frequency is given, you find lambda from here, and lambda by 4 is the size of antenna, correct? Now let us see here. So what is the key point here? That if you want to transmit a signal, antenna size should be minimum lambda by 4, right? So here at least minimum lambda by 4. Now see, directly come to this point. You don't have to read everything. I have already read it for you, and I am only telling you the important points, right? So for an electromagnetic wave of frequency 20 kilohertz, right? In previous example also 20 kilohertz was there. Wavelength is 15 kilometers. How do we find? Let us see. So 3 into 10 to the power 8. And what is frequency? 20 into 10 to the power 3. And this into lambda. So here lambda is coming out to be 15 kilometers, right? That you can see, very simple calculation. Lambda by 4 is going to be 15 by 4 kilometers, right? Kilometer. Okay, so you can't have an antenna which have a size of 15 by 4 kilometer. You can imagine, right? That's impossible. So that is one thing which limits the, which is a constraint if you want to transmit 20 kilohertz, right? So that means somehow you have to increase the frequency. Okay, that is one important point. Another important point now. So the detail of this is you don't need to know why lambda by 4 this, right? So in some next video I will take up, I will explain you that roughly why lambda by 4 is required. Okay, so in just one line, if I have to say right now, that antenna works on dipole, right? And it is basically electromagnetic induction. So if you have one wave like this, electromagnetic wave, then this is lambda by 4, right? So you are covering the maximum variation. And suppose if you have an antenna, then because of this electric field, what will happen? Motional EMF will be generated, right? So if your antenna size is like this, then motional EMF generated will be more effective and generation of electromagnetic waves will be more effective. Fine. So in very, very brief, I have told you. Fine. Now, next point. Very quickly, we'll go to the next point. So next point is effective power radiated by the antenna. This is only one key point here, proportional to L by lambda square, right? So here, what is L? Linear length of the antenna, and this is lambda, correct? Now, if lambda here is 15 kilometers, power, this is power radiated, right? Inversely proportional to lambda square. If lambda is very large, power is very, very less, right? So then again, finally, now come here for a good transmission, we need high powers. And hence, this also points out to the needs of high frequency transmission. So what is the key point? Conclusion. Our conclusion is that when we are generating a speech signal, which has a frequency in the range of 20 kilohertz, we cannot transmit it as it is, right? We have to mix something we have to do so that we increase the frequency, right? What is that something? That something is called amplitude modulation, right? That can be done from amplitude modulation, that can be done from frequency modulation, that can be done from phase modulation. Now, good news is that we have to study only amplitude modulation, right? So let us see. This you can just go through. It's not that important. Yeah. So here now, this is amplitude modulation, directly coming to the key point. So now what happens? Here we have to be careful. So if you just understand this heading, right, only up to here, you will be able to solve all the questions by yourself, right? So just listen for 5 more minutes. Amplitude modulation, what do we do? So this is a signal. See here, this is a signal. This is called modulating a signal, right? Modulating. This signal you want to transmit. This omega m is, let us say, 20 kilohertz. Fine. The speech. Right now I'm speaking. So let us, that frequency is 20. This is your signal, right? This is what you want to transfer from one point to another point. But since omega m is small, that is why lambda is more, C equal to F lambda. And there are problems, right? What problems? Size of the antenna and the power radiated, correct? I think you're following. So what do? We generate one carrier wave, omega c, carrier, right? Carrier means it's like something which is carrying your signal. So this is the signal. We generate the signal. Now omega c, what is your requirement? You want high frequency. So we generate the signal of high frequency. This is called carrier signal, right? CT. Fine. Then after that, name is amplitude modulation. So what do we do then? We superimpose the signal, right, in the amplitude of this. मतलब अगर सपोज आपको एक चिट्ठी भेजनी है कहीं दूर पर, है ना, और कोई आपके पास सपोज घोड़ा है, ऐसे घोड़ा बना लो, ऐसे तो घोड़ा बनाया आपने, है ना, दिस इज घोड़ा, हॉर्स लिखते हैं, and this is horse is carrying one letter, right? Chitti. So what is chitti here? Chitti is this, right? This is what in this your message is there. But since chitti cannot fly, right, or cannot walk, so that is why you're using some carrier, right? That carrier here is horse, right? और जैसे आपने देखा पहले कबूतर था, राइट? तो कैरियर वाज कबूतर, एंड देन हियर नाउ ये क्या है, ये कबूतर है और घोड़ा है, राइट? जो भी है, बट दिस इज नॉट इंपॉर्टेंट फॉर यू, है ना? So what do we do? We superimpose the signal, right? This is the important point here on in the amplitude. So it's called we are modifying the amplitude. That is why the name amplitude modulation. Correct? How do we modify? Very simple. In this AC, we superimpose this, right? So let us see, just 2-3 more lines and you are done. So this is now modulated signal. This is what? This is modulated signal, right? Here it was modulating signal. Fine, understood. Now, here what are we doing? AC plus the signal, AC plus AM sin omega MT sin omega CT. And then after that, you take AC outside. And then here, AC is 1 plus AM by AC sin omega M sin omega CT. Correct? That's it. Now, here, what happens? Okay. So omega AM by AC is called modulation index. Very important thing. You will see questions are based on this directly. What is modulation index? AM by AC. AM is what? The amplitude of modulating signal, right? And AC is what? Amplitude of carrier signal, correct? Mu is the modulation index. Fine. So this we have written like this. After that, this is sin A sin B. We'll use sin A sin B formula. And when we use sin A sin B formula, this is the most important thing, right? This is the most important thing. All the questions are based on this. So this is modulated signal here. Now see very carefully. When you do sin A sin B formula, that time there are three terms, right? It is superposition of three terms. One term has frequency omega c, another term has frequency omega c minus omega m, another term has frequency omega c plus omega m, right? Mu, what was mu? Modulation index. Now, how do you remember this, right? What is the surprising thing here? What was the frequency of the signal which you wanted to transport? Omega m, but here you don't have any term which has the frequency omega m, correct? So there are many questions which are just based on this. That an amplitude modulation signal, which frequency is missing, which will be missing? Omega m, right? Now, another important point here is omega c minus omega m and omega c plus omega m are called lower side and upper side frequencies, right? See this here. This is this one, omega c minus omega m, omega c plus omega m, right? This term, and omega c itself. And amplitude of this term is AC, and amplitude of these two terms are mu AC by 2. Now, another important thing which you can remember this as a fact, mu is kept less than 1 to avoid distortion, right? Till now, they have not asked any question based on this, but they can ask, right? Because it is written in NCERT. That's it. We are done. That's it, right? So in conclusion, right, you can rewind and see just one line. If I say that the speech signals have lower frequency, therefore more wavelength, bigger size of antenna, less power radiated, right? Key points you can write, make short notes, key points, and plus 4 marks in JEE mains, right? Nothing can be simpler than this. And after, so what do? We take one high frequency wave, and in the amplitude of that, we superimpose our signal, right? So this is, and then after that use sin A sin B formula, and we end up here. Correct. This is lower sideband frequency, high, and then mu is modulation index, right? If you just remember this, in FAB attempt 2021, all the questions you will be able to solve, right? In other attempts also. But in this video, I've taken only those, so that is why I am taking the reference of only those. Okay, so let's go. Let us see. Let us see what we have learned, whether it is useful or not, right? So first question. See. Now, first question is that statement 1, speech signal 2 kilohertz, right? Used to modulate a carrier signal of 1 megahertz, right? It is matching with what we have studied. The speech signal has less frequency. This has higher frequency, carrier signal. The bandwidth requirement of this is 4 kilohertz, right? Now, bandwidth. What is bandwidth? See here, three terms came, right? One term frequency was omega c minus omega m. Another term was omega c, right? Just now we have seen another term, omega c plus omega m. So now bandwidth is the bandwidth you have studied in AC circuits also. Bandwidth is high minus what is the range of frequencies, right? Range is what? Highest number minus lowest number. So this minus this. So bandwidth I'm writing as B. So if you subtract these two, you're going to get 2 omega m. There are questions based on this, right? What is bandwidth? This is a question of JEE mains, right? What can be simpler than this? So B is equal to 2 omega. Now here omega m is this. So the frequency in hertz I'm talking about, right? So here it is in hertz, it will be omega m. This is modulating signal 2 times of that 4. This was correct statement. The sideband frequencies are 1002 and 988. Now see here, what will be omega c plus omega m? So omega c plus omega m now I can write as fc minus fm, and here fc and fc plus fm, right? No problem in this. Why? Because you know that we can convert hertz into radian. Okay, so fc minus fm will be equal to what? This is 1 megahertz, so 10 power 3 kilohertz, so it will be 1000. So it is then, this is 998. Why? Because it is 1000 minus 2, and fc is just 1000, and this is 1000 plus 2, right? This is 998 and this is 1002. So what happens now? 1 is also correct, 2 is also correct. So it's all 1 and 2 both are correct. This is correct, right? Very simple. Just that if you know amplitude modulation, you can solve this question, right? It will take only 20 seconds for you to solve this question in the exam. Free ke number hai. This is free. These are free marks. Now after that, see the simplest question. See here, audio signal M modulating, right? 20 sign this. Amplitude modulates a carrier, right? This is modulating carrier percentage modulation. What is the formula? AM by AC. What is AM? 20. AC is 81 by 4. Percentage 25%. Question solved, right? 10 seconds. You can solve this question plus 5 marks, right? Okay. See here. One more important thing. This question came in first 20 questions of mains, right? This one. First 20 questions. So in this, you did not have a choice, but in this question, you had a choice in this one, right? But there is a question. Factors, there is a question in JEE mains. Okay. Now next one. Next one is if the high frequency modulating a carrier is 5 kilohertz, then the number of AM broadcast stations accommodated in 90 kilohertz bandwidth are, right? So now, just now we have seen what is the bandwidth. Bandwidth is 2 FM, right? Why I'm writing 2 FM? Because it is in hertz. If it is in radian per second, I will write 2 omega, correct? So what is the bandwidth of the signal? 10 kilohertz, right? See, nothing can be simpler than this. Bandwidth is 10 kilohertz. Now question is the number of AM broadcast stations accommodated in 90. So one bandwidth is 10. In 90, how many will come? 9. See, it is that simple, right? So if someone is telling you that you can leave a communication system, then you cannot that decision will be very, very bad decision, right? You can't leave. It's very simple. If you just spend 15 minutes on this video, you'll be able to solve the question, right? Now, next one, see, if a message signal of frequency FM is amplitude modulated with a carrier signal of frequency FC and radiated through an antenna, the wavelength of corresponding signal, right? Now, here we have to see what happens now in amplitude modulation. What we have seen, we have written AC plus AM sine omega mt, and here sine omega ct, right? So you remember beats. In beats, what do we do? In beats, there is one term here, there is another term here, correct? This is the similar expression. Now here we know that since omega c is very, very large as compared to omega m, correct? So if you draw its curve, it comes out to be something like this. So suppose if I draw omega c, then omega c will be like this, right? Or what I can do, I'll just show you the actual curve here. See, this is the curve. This is very high frequency, less time period. See this one, high frequency, less time period, right? Here, this is low frequency, right? More time period. If you superimpose, it becomes like this, right? So since this variation is very large, you can attribute this variation to the amplitude variation and roughly take wavelength as the wavelength of carrier signal, right? So if question comes that what is the wavelength, then you will have to take that as an amplitude modulation. you can consider the wavelength of carrier wave, right? I hope you understand this point. This is, since this variation is very small as compared to this, right? If you consider one small region here, any small region, then this variation you can neglect. You can say that, okay, this is a wave which has wavelength equivalent to the wavelength of carrier wave. Fine. So I hope this, you understand this. And then if you understand this directly, then what will be the answer? The answer is going to be C by FC. Right? Fine. Let's see one more question. So this question is, so this question I will leave for you to practice, right? So based on what we have studied, you can solve even this question also. Fine. So if you are watching till now, then now chances are 99% you will be able to solve the question in JEE Mains. Fine. I will be now compiling other communication systems questions, semiconductor questions, and other means only topics I will be compiling, right? So please like this video, please subscribe this channel, and then you have to please share it with your friends. That will give you motivation, more motivation, and then I will upload more and more videos, right? So that, and then all the videos will be focused, right? Just, I'm not uploading just for the sake of uploading. See, I have to think so that I'm uploading videos so that I can save your time, right? Like that, if you have to search for communication system on internet, then at one place you will find questions, and one place you will find theory, and then in theory also there will be many things which are not needed. So that is why I thought of making this video. In just 10 to 15 minutes, you can get +4 marks in the exam. What can be better than that, right? So thank you very much. I end here, and then we'll meet in next video. Thanks a lot. See you all. Thanks.